Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to work over on the steam Stoker engine. We are making some good progress here. I got all the crankshaft, the connecting rods, the crossheads all installed, and they are freely working. And up next, I want to kind of change gears a little bit, and we need to get up into the head of this where the cylinders are and start getting some things going on it. The next thing that has to be kind of connected up here on the crankshaft are the eccentrics, which will control the valves. The valves basically port the steam into both sides of the piston to push on the piston going back and forth. On this particular engine, we basically have some sleeves, some cylinder sleeves that fit up in here. You've got basically it's almost like a piston that goes back and forth in there that ports the steam into the right direction going into these engines. When I got this engine, the sleeves that were in here were very pitted beyond really being able to use, and we actually were able to press those sleeves out. They are where you can replace them. I was able to get them out with a hydraulic press. It took quite a bit of work, and we need to make some new sleeves. There's two of these that fit down in the bottom of the casting here with the cylinders on it. So today what I want to do is get started on this. We're going to take the head off, get it kind of ready where we can start looking at it. To make these are made out of cast iron, and I had some cast iron cylinders poured that are oversized. Obviously we're going to have to machine these down to size, but this is what we're going to be working with. I just made a pattern, had these cast in cast iron, and hopefully they will do the trick to get down to the sleeves like we need. So let's get started. I've got the gantry crane in here. We're going to unbolt the cylinder from this, get it over here where we can kind of take a closer look at things. I do have blueprints on the cylinders, or on the sleeves rather, so I know what we got to make, and then we're going to get started. See if we can start getting these things knocked out. Let's get this head off. So I'm going to start out by saying that I was calling this a cylinder head, and I know some of you guys are going to say, that's not the right term for it. My brain wasn't engaging when I was doing that a while ago, and I actually went and looked at the parts layout on this to look and see what they actually called that, because it wouldn't come to me. It's a cylinder block. The cylinder heads are actually the covers that cover the ends up. I knew that. It just, like I said, it wasn't coming out. Right now I'm going to go around. There's basically a bunch of bolts that are holding this in place, bolts, studs, and nuts. I'm going to go around and loosen all these up, and I've got a strap on this that will support it so that we can get it disconnected here. Let me get all these nuts loose. There are quite a few of them holding all this together. All right, this should be the last one. And as I loosen it up, I'm seeing it kind of come forward just a little bit. Let me get a little more tension on this strap. There we go. And it is off. Take this over here, and we'll just set it down on the planer table. So just kind of showing you what's going on inside of this. These are the cylinders, of course, where the pistons are going to go. I've talked before about steam engines are different than internal combustion engines. An internal combustion engine, you'll have the explosion that happens at the top of the cylinder where it either compresses gases in a diesel, or you have an ignition source like a spark plug in a gas engine, and that will push the cylinder down. And then it'll come back up, and then usually there's 2 strokes, and then it'll go again and press it again. And that's basically how your compression strokes go. On a steam engine, it's actually putting steam into this head. Steam wants to expand, So it's going to push on that piston and push it back down. But unlike in a gas engine, it's actually putting steam on both sides of the piston. So when the piston goes down in the bottom, it will switch a valve down here, it will change the porting, and basically then it'll put steam in the bottom of the piston and push it back up. So every revolution of the crankshaft, you've got 2 push strokes going on rather than one, and then a wasted stroke, and then boom, boom, boom. That's an internal combustion engine, whereas this one's going to go boom, 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 boom. So you can see it's just acting a lot quicker. Now to port that steam, basically you've got live steam that will be going up into a steam chest. In this case, the steam chest will be, I'm not exactly sure where it is on this, I'd have to figure it out, but it's going to be somewhere in probably one of these pipes here. The steam will be coming into, and it'll be basically pressurizing on the inside of this. There will be steam. The valve is going to slide back and forth where it can pick up that pressurized steam, and when it does, is going to port it into one of these holes down here in the, you can kind of see these little gaps in here. It's going to port it up into one of these openings in here, and that's going to push it in. There's openings on both sides of this. So you can kind of see them right here, I think. Turn that a little bit. You can kind of see them on this cylinder, and you can see them back there in the back, and you can kind of see them here. In the center stroke, it's just kind of open. That is, I'm going to have to study it. That may be where you got pressurized steam, or that may be where the exhaust is going to be going out to the exhaust, and there will be a separate port that the exhaust will go out of and basically just escape from it. But these are the cylinders that we've got to do, or make the new sleeves. So this is one of the sleeves that I pressed out, and you can see it's just basically a cylinder. This is not all the same diameter on the inside. There's kind of a little hump here in the middle. That's where the valve kind of goes back and forth on. And there's one on the back side, and it kind of is recessed in. But it's also got all this porting around here for the different places for the steam to move around based on where that valve is sliding back and forth on the inside. And as we get this thing back together, you guys will kind of see this a little bit more. I will note that when we press these out, they did break. I kind of just JB welded these back together just so that I would have an example of what they look like. So these are not perfect by any means, and you can see there's a lot of pitting on this. This is that center section in there it's just kind of open to the steam. There's a lot of pitting on these. They're not in the greatest shape. They have to be replaced. So let me go see if I can find my blueprints, and we'll probably come up with a game plan on how to machine our cylinders, our castings, to get these things turned into a proper sleeve. So let's take a look at the drawing here. This shows pretty clearly what we got to do. So this is basically just a side view and then a sectional view of the sleeve. Over here we got some other sectional views kind of showing the porting in there. Not too worried about this right now. Basically, all I'm doing in this step that I'm doing today is we're going to rough this out, internal and external dimensions. We're going to leave the OD larger than what it needs to be. We're going to leave the internal diameter smaller than it needs to be, so that we're going to be finishing this out later on, but I do want to get them rough turned. Now the final dimension on this is 2 7/8 inches in diameter, and 3 1/4 inch diameter. 3.255 is actually 5 thousandths oversized. So this will have a 5 thousandths interference press fit up inside of the cylinder block. And what we will do is we will actually freeze these bushings before we press them in, which will shrink them. We'll heat the cylinder block up, which will make it a little bit larger. And honestly, the part will probably just drop down in there once we do the shrink and the expand with the temperature, and then when the temperature normalizes, it will go back to its normal size, and we'll have a 5/1000 interference fit. We may have to press it in. I'll have it over at the hydraulic press in case we need to, but according to the blueprints, 5/1000 is what they are recommending for the press fit on this, on a 3 1/4 inch diameter. Now, when I turn these, instead of going to 3.250, I'm going to probably turn them about 100 thousandths oversized. Again, that just gives me some metal to work with later on. The internal on this is a little bit different. If you look, it actually has a, you got two areas in here. This is the area where the valve kind of slides back and forth on. And as it does that, it's only going to be in contact there. And then that bore diameter is 2 7/8 inch. I'm sorry, 2 3/4 inch. That's this dimension here. And you can see it's actually oversized. This is 2 7/8. It shrinks up to 2 3/4. Goes back to 2 7/8. Shrinks up to 2 3/4. Back to 2 7/8 on the end. And again, we're just going to make that a little bit. We'll turn that inside diameter a little bit undersized so that we have more material to take off. So if you look in here, you can see the porting. It kind of shows that as well. This area right here is where the steam will come into the sleeve. So the steam chest will be pressurized. I will note that these square ports here and over here, in the original ones, these were actually cored into the pattern so that when you cast this, those were cast in there. They were not machined in later on. I opted, when I was doing this, to instead of making the patterns with the cores and everything in there, we just made a solid sleeve. I will note here too that there is a left and a right, so there are two mirror images of this. If I had done the cores with the pattern, I would have had to make two patterns. There have been two core boxes. It'd have been a lot more involved. And honestly, guys, for just two sleeves, it was going to be easier to machine these ports than it was to actually make a pattern to cast them in there. Back when they were doing tons of these, the exact opposite. Mass production, yeah, let's fake the time, we'll core it out, and that'll save us time in machining. But in here, it was going to take me longer to make the pattern than it would to just machine them, so I opted not to do that. So we just have a solid core. But basically, the steam comes in here. There's a slide valve again, and it basically, when it's all the way forward, it blocks the steam on this side, so the valve goes to this side of these ports. At the same time, it's to this side of these ports, so the steam can go into this side. That will then feed the steam into the cylinder, and that will push the piston back. Once the piston gets pushed back, the valve slides to the other side of this port. When it does that, the steam can come out of the cylinder and into the exhaust, which are these are the exhaust ports on either side. So it's basically just determining whether the steam from the steam chest is being ported to the cylinder or whether the steam from the cylinder is being ported to the exhaust. And that's what's going on inside of this valve. Anyway, I thought I'd show these. We do have the blueprints on these, so that's going to make life a lot easier. But again, for today, all I'm worried about is just getting an internal and external diameter machined off of these, and we will do the porting later on. So here's my thoughts on how to get these things machined. So the step one is we have to get this rough casting turned into this sleeve that has the proper outside diameter, the proper inside diameter, and that profile that we talked about before. It's going to be a combination of boring it as well as turning the outside. I'm going to do this over on the lathe primarily or entirely. That's kind of my game plan. So I think what we'll do is we'll go in and we're going to chuck this up in the 3-jaw chuck. And I'm going to take a bullnose center and put up in this end. I know that's not going to be running perfectly true, but we got plenty of material to work with. That'll just kind of give it some support. And I'm just going to turn the outside diameter just enough until it cleans up. It will not be to the final diameter. It's just going to be enough to clean up. And then that will give me a better surface to grip in the chuck. I will then flip it around, gripping on the little section that we just turned on the end. I'm probably just going to turn a section on the end. And I'm going to do the same thing on the other end. We'll put the bullnose center in, and we're going to turn a little section here. And then I will take the bullnose center off, and on that turn diameter on this end, I'm going to put my steady rest on the lathe to give it some support, and then we'll use a boring bar to come in here and start boring out the center. And I'll probably start with just getting it down close to the final dimension, not take it to the final dimension. Once we get a good bore on the inside, I'm going to take it out of the lathe. We will then move it over and put it onto a expanding mandrel, turning between centers. That will keep it running concentric on that bore, and I'll start working on cutting the outside diameter, and we'll cut that concentric to the inside diameter, which will be turning on that mandrel. That's my game plan. It may change as we move through the process. It may evolve. As far as the porting goes, that's going to be done over on the milling machine. And yes, Ginger's going to come check out and supervise, make sure that my plan is solid here. Thank you, Ginger. As far as the porting goes, we'll probably do that on the milling machine. A couple of different options on how I can go about it. All right, Ginger, move on. I can either put this into a rotary table with a 3-jaw chuck and with some type of support on the end, and basically rotate this around on the milling machine to cut the ports all through there in the different positions. I can determine from my drawing what angles I need to be at on the rotary table to get in the right position for each one of them. That's one step, or one possibility. Another possibility is I may reach out to some of my CNC friends that may have a milling machine with a 4th axis on it, where they could basically do the same thing but do it in a CNC machine, where I wouldn't have to manually crank in all the angles and stuff. Let the computer do it all for you, which would be a lot easier. Again, I got to find someone that can do that and is willing to do that, but that is an option as well. I can do it in-house, I think, with some work. Either way, we'll get it done. But that's kind of my game plan. Let's go to the lathe and just see if we can get started on this thing. Over here at the Monarch lathe, I've got my 3-jaw chuck in here, and I'm going to take this first cylinder, cast cylinder, and I'm going to put it into the chuck. I'm just going to snug it in there right now, just barely tightening that up. And then I'm going to come in. I've got a bullnose center. So this bullnose center basically is just a big center that is big enough to fit up into the hole that we've got cast into there. And I'm just going to put this in here to just kind of roughly get me centered up on here. Now this is a cast piece. That inside bore is not perfectly true. The outside is not perfectly true. We've got a lot of material we're going to take off of this. We will be turning this true. So basically, I'm just going to use that as a reference to get started on, and that should hopefully give me some support out here more than anything else. My first step here is I'm going to just true up this end so that I have a nice round surface that I can then turn this around and chuck on. I will do the same process again. We'll true it up, and then that will give me something I can put my steady rest on to give me some support in this while we bore it out. So that should support it. Let me go ahead and finish tightening up my chuck now that I've kind of got it where I want to hold it at. And let's fire the lathe up and just take a look at it and make sure that the run out is not excessive. It is not going to run true because it's a casting. But we do want it to be fairly close. So here we go. And again, I'm happy with that. Let me touch off here. It's going to take a little bit of a cut since that's going to be interrupted. All right, so that is cleaned up all the way around. So now we're just going to flip this around over here in the chuck. We'll grip on this round area, and we're going to true up the other side to give us something to run on there as well. center back in here. And same thing, I just want to get it trued up enough to be able to run. We're not going for any final dimensions here. So now I can get my steady rest in here. Because we're going to be boring this, I'm going to need to be coming in the end. So we'll need to take the center out and be able to put a boring bar up through there. But I do want to have some support out here. So my steady rest will just kind of fit down in here. I'm going to need to open this up. Let's see if I can slide that on there. I can. I'm going to go in a little ways, get it off the end. I'll tighten up the bottom here. Just bring my 3 wheels up until they just touch that area in there. Lock all those in place. So now basically I've got 3 points of contact. There's rollers, ball bearing rollers in this, and that's going to support this out here on the end so that it's not flopping up and down. And when I start boring that, that'll just make sure that it stays nice and true. And I got a boring bar. This is the biggest boring bar that this lathe will hold. My holder will hold. And what I'm going to do is I'm going to run that pretty much until I just got a little bit of a gap there, and I'm going to extend the boring bar until it basically comes out the inside there, which is pretty much the whole length of the bar. Ideally, I would like to do this over on my bigger lathe, mainly because I've got a bigger boring bar, bigger diameter boring bar that would be more rigid, but I don't have a steady rest over there on that lathe, at least not one I can use. I do have one, but it's like everything else around here needs to be fixed, it needs to be worked on before it can be used, and I just don't have time to do that right now. So, you know, that's going to be sticking out a ways, but we should be able to get it done. I'm just going to have to probably make fairly light passes because a long boring bar is going to have flex in it, and we'll just kind of have to sneak up on our final number. I will say too that right now I'm not taking this to a finished dimension. We're just going to make it a little bit on the large side, and we'll come back and finish it after we cut all our ports in. So the smallest diameter that we finished in there is going to be 2 3/4 inches. We're just going to bore it probably 100 thousandths undersize, and after we get everything machined in there, we will come back and do our final boring on the inside and get it to final size. Right now, like I said, I just want to get this thing roughed out. So I think we are ready. So let's make a pass down through there and see how things go. So I'm going to start by just kind of feeding my bar in there. Because that's a rough cast and I don't know exactly where it's going to hit first, so I'm just going to make some passes in here and just kind of fish around until I touch off somewhere. See, I'm hitting right there. All right, we'll start right there. That's going to start with an interrupted cut. And because it is an interrupted cut, guys, I'm going to take my time here. And we're just going to kind of go slow. At least until we get make lighter passes until we at least get a full cut going in there. Starting to make a little contact there. I'm just Going to do another 40 thousandths cut here. Just feeding in until I hear it start to cut right there. Do another pass, rinse and repeat. We'll keep going here until we kind of get a uniform cut going down through there, and then we'll stop and get a measurement. As happens around here from time to time, you have a plan on how you're going to do something, and when you get in here and start doing it, the plan just doesn't work out, and I think that's where we're at now. This boring bar that we've got in here is just not getting the job done. The problem is that it's sticking out so far that when you get out here, the leverage pushing down on this thing, it's just, the machine's just not rigid enough to bore something this large with this diameter bar. So what am I going to do? Well, like I said before, I would really like to do it over on my bigger lathe, but I don't have a steady rest to give me the support I need without spending a lot of time doing some work to a busted up steady rest. It's really not even the right steady rest for that lathe, but I've got intentions of one day kind of making it work. I could do that, and that's an option. But I think another option that I have is that I might be able to bore this out over on my horizontal boring mill using a bar going through here. Basically, I would clamp the work down to the table. I would have a bar going all the way through that's supported on both ends, and have a cutter that's swinging inside that bar, moving around and around and around, and basically just move the work over the cutter, which is line boring for all intent purposes. I'm kind of inclined to go that route. I've never really done line boring like that on that machine in there. Well, I may have one time. Anyway, it's kind of a new experience for me, but I think that's what I want to look at doing. So I'm going to get in there and see what's going to be involved in me getting that machine set up to do some line boring, and we may try to line bore this. The nice thing about this is that I've got plenty of material on the outside diameter. Once I get a bore established that's uniform, I can put that on a mandrel over here and then turn the outside that will be concentric to the inside. And even if, again, we got some run out when we first start, by the time we turn the metal down, it should be running true. So that's kind of the direction I think I'm going to head. So let me get in there and see what we can do about line boring on the horizontal boring mill. After doing some really kind of studying things off camera and trying to come up with the exact game plan on what I want to do on this part, I think that I have decided that instead of doing this on the boring mill, I could have done this either on the boring mill or on the big lathe. If both of them were going to require some time and some setup. If I did it on the boring mill, I was going to have to set up a boring bar and do some boring cutters and stuff. That's an exercise that I want to do, but I really, at the end of the day, just decided that I really just need to take the time and fix my steady rest on the big lathe and just do it over there. I could probably get the job done faster on the boring mill, but here's the deal, guys. In the how many years that I've had this big 28-inch monarch lathe, I have needed that steady rest probably half a dozen times and haven't had it, and every single time had to come up with another way of doing something. And here I am again in that same situation. I think the time has come to just take the time to fix the steady rest so that we can use it on this project. And then when I need it on the next project over there, it's done, it's finished and everything else. So in reality, the way that the YouTube videos get posted and everything, I'm just thinking in my mind how this is all going to play out. I'm probably going to fix the steady rest over there, and that video is probably going to get published before this one. Things don't always get published in the order that I shoot things in my shop. So don't be, by the time you're seeing this video, very likely you've already seen me finish the steady rest, but in the real world, the steady rest isn't done yet. So it's just kind of the way it is. But I think that's how it's all going to come out as I'm kind of planning my video releases and everything else. I'll probably go ahead and get that done next. But we're going to take the time, get the steady rest finished up, and we're going to try to board out over there on the lathe, which I think is really the right solution here. So with that, guys, today, this is a wrap on this video. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon out there to get notifications when new videos are posted. As always, a big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships, all of which are great ways to help out my YouTube channel or any other YouTube channel that you really like and feel like you get value out of. And with that, guys, we're going to sign off. We'll get out of here. We'll catch you on the next video. Again, as always, thanks for watching.